Hello guys, my name is Bino, and in this video we'll be going through question 4 from the April 6, 2021 Mathematics N6 question paper. Question 4.1 states that we must determine the general solution of dy over dx plus y sec x is equal to x cos x. So we use this formula: y multiplied by the integration factor is equals to the integral of q multiplied by the integration factor dx. Let's define what our q and integration factors are. The q is the function after the equal sign, so each and everything after the equal sign will be equals to q. So q is x cos x, and before we can determine the general solution, we have to make sure that dy over dx, the coefficient of dy over dx is equals to 1. So we must make sure that always there is no any other number or function before dy over dx. And the function after y, we call it p. In this case, p is equals to sec x, and the integration factor is equals to e to the power p dx. So let's determine what our integration factor is. So integration factor is equals to e to the power p. In this case, our p, the function after y, is equals to sec x dx. The integral of sec x dx is equals to, from our formula sheet, is equals to ln of sec x plus tan x. And we know from our laws of logarithmic functions that if you have e to the power ln of 5, this is equals to 5. So if you have e to the power ln of a, this is equals to a. So in our case, the integration factor is equals to e to the power ln of sec x plus tan x. So e to the power ln function is, so the integration factor will be equals to sec x plus tan x from our rule. So the integration factor is sec x plus tan x. So the next step is for us to multiply the integration factor to q. So the integral of q multiplied by the integration factor dx. So our q is the function after the equal sign, the x cos x. We multiply it with the integration factor. Our integration factor in this case was sec x plus tan x dx. So from here, we know that sec x is equals to 1 over cos x, and that tan x is equals to sin x over cos x. So from here, we can distribute the x cos x inside the parentheses. So x cos x multiplied by 1 over x, 1 over cos x, plus x cos x multiplied by sin x over cos x. The cos x will cancel out with the cos x. Cos x will cancel out with the cos x. So q multiplied by integration factor dx will be equals to x plus the x sin x dx. From here, we distribute the integral sign and the dx inside the parentheses. The integral of x is equals to x squared over 2 plus the integral of x sin x dx. To evaluate the integral of x sin x dx, we have to use integration by parts. So the formula for integration by parts, we have the integral of f of x g prime of x is equals to f of x multiplied by g of x minus the integral of g of x multiplied by f prime of x dx. So we have to figure out which one will be equals to f of x and which one will be equals to g prime of x between x and sine x. So the sine x, the x is an algebraic function and the sine x is a trigonometric function. According to the Euler rule, the first one that you come across going to the right will be equals to f of x. As you can see, the a for algebraic function comes before the t for trigonometric function. So the a, in our case, x will be equals to f of x, and g prime of x will be equals to the one which appears late. So we differentiate f of x and integrate g prime of x so that we can get g of x. So the derivative of x is equals to 1. The integral of sin x is equals to negative cos x. So the integral of x sin x dx will be equals to f of x multiplied by g of x. F of x is x and g prime of x is negative cos x. So let's write that negative there, minus the integral of g of x multiplied by f prime of x. The g of x is negative cos x, and that negative multiplied by this negative will be positive, multiplied by f prime of x dx. Our f prime of x is 1, so anything multiplied by 1 is equals to that thing dx. So there is no need for us to write the 1 there. So x, the integral of x sin x dx is equals to negative x cos x plus the integral of cos x, which is sin x plus c. So the integral of x sin x dx is equals to negative x cos x plus sin x. So since I already wrote the positive, let me introduce the sin x minus the x cos x plus c. So this is our q multiplied by the integration factor dx. So we go back. So this is the formula for our general solution. Y multiplied by the integration factor is equals to the integral of q multiplied by the integration factor dx. The integration factor we determined as sec x plus tan x, and the integral of q multiplied by the integration factor dx we just determined as x squared over 2 plus